Welcome to FireVoxel. In this video, I'm going to demonstrate how to use existing HIP atlas and template to register a new case and move the atlas on the target image. In the first video, we reviewed how to create the atlas and how to save it in the combined FireVoxel document format. So this is our atlas. Just as a reminder, it has 6 layers, some ROIs for hip, femur, and cartilage, and also the ROI that will be used for registration. Now we need to load the case, and we were provided 6 different cases. Each folder contained nifty files for 4 different modalities, and we use a W modality for this experiment. So double click, we load this case. If you left double click on the image, you could review info, and this is a 1 mm³ resolution. So next we go to workflows and hip atlas registration, and we press initial alignment of the image. Note that software automatically rotated the image to its native projection, and those projections, this native projection is different from one in template. Some of the target cases were provided in the matching projection, and some were provided in this mismatching projection. So the issue here is that the relationship between direction of anatomical axis and the rasterometric axis differ for template and for image. It would be easy to fix automatically in the when we have automatic workflow. For now, we just fix it manually by press on the image document to make it active and go to transform, rotate orthogonal, and we just need to rotate this image 180 degrees around z-axis. So this is the new image on the left because it says rotate orthogonal. We close the original image, and just to save it so we don't have to repeat the separation again, we save it to target 1. Let's call it target reoriented. So now we will be able to use this image for without further correction. Okay, so let's go back to our workflow and press hip initial alignment. So everything seems to be fine now. Now the whole purpose of this first step is to obtain the fine registration parameters that would roughly, which would roughly align the image to template. So we need to specify the name for that affine parameter, and then we press OK. Just use the default hyperparameters in dialog box. You don't need to change anything. Press OK, And now the processing runs. Um, all right, so operation is completed. We see that the target image was actually moved on top of the template at this step. We don't need the image itself. As I said, we only need that affine parameters, and we obtain them. So to make it simple, we could just close this document, the template document, and then reload it without that image. And now we have that affine transformation file saved. Now we go back to workflows, Hip Atlas registration, and the second step is deformable registration. And the only we could keep the hyperparameters as they are. We just need to specify this initial transform of this exact file name from the previous steps. And once it's specified, we could run our operation. The only comment here is that similarity measure. The cross correlation works quite well, and this is a well accepted and popular measure for registrations. However, there is a newer and more advanced self-similarity context, and in many cases it works better. So that this would be another measure to consider. In this experiment, we are going to try cross correlation. So we just press OK, and it goes, this deformable registration goes through several steps. I just want to show you that the deformable registration probably takes close to 15 minutes at the moment, depending on the parameters. But you could see that all the processors are mostly occupied, and this is a 16-core, 32-thread processor. All right, now registration is completed and the atlas and template were moved to the target image document. So you see that all of those 6 layers were moved on top of the image layer. We don't really need template. layer anymore, and we don't need the union layer. But other layers, anatomical structure from Atlas, and now they are overlaid on top of the target image, and we could see that the alignment is quite good. If you press this item on the right on the toolbar, you could see it in 3 projections, and note that the cursor is synchronized, so you could see alignment and various projections. So next, if you would like to reuse those Atlas components registered, you could export them. You could either save them as DICOM or as some image formats, for example, Nifty. So you just type in the name, you specify Nifty, and you say save. You press no. And this is how you save the results. Thank you very much. This concludes the presentation.